The structure and ion dynamics of solid electrolyte. Usefulness of NMR in research and development of solid-state batteries. LIBs have many advantages, such as high voltage output and high energy density, and are now used in a very wide range of applications and greatly support and enhance our everyday lives. Recently, solid-state batteries with solid electrolytes are attracting a lot of attention of researchers in battery fields. Nuclear magnetic resonance spectroscopy is a powerful method to probe the structure and ion dynamics of solid electrolytes. NMR can provide structural information reflecting the local environment of nuclei commonly used in battery materials such as lithium, fluorine, phosphorus, boron, and sodium. This leads to knowledge that is closely related to the electrochemical properties of batteries, such as the identification of chemical structures and structural changes associated with charge-discharge cycling. In addition, NMR can also be used to evaluate ion dynamics in electrolytes, which closely relates to ion conductivity. These data are very useful for the design of solid electrolytes. The structure of solid electrolytes in LIBs. Structural information on solid electrolytes can be obtained by solid-state NMR of the nuclei constituting the electrolytes. Here, we would like to introduce the results of 31 phosphorus NMR measurements for sulfide solid electrolytes. The measurement of solid-state NMR spectra using Atoma's probe is effective for the structural analysis of solid electrolytes. Sample is packed in a sample tube and placed in the rotor carrier. Submit measurements with intuitive and easy-to-use software, Delta. The sample is brought to the Atoma's probe and spun at the magic angle. The peak widths in the spectrum can tell us whether the sample is crystalline or amorphous. The degree of crystallinity and the ratio of different unit structures within the electrolyte can also be quantitatively determined by peak deconvolution. The ion dynamics of solid electrolytes in LIBs. AC impedance measurements are often used to evaluate the ionic conductivity of solid electrolytes, but they are affected by other properties of the solid electrolyte, such as its bonding to the electrode. To investigate the ionic conductivity of the electrolyte itself, it is important to study the local ion dynamics. Diffusion lithium NMR is a powerful method to investigate bulk ion dynamics and ionic conduction mechanism. NMR diffusion measurements are performed using a GR probe and magnetic field gradient power supply. GL's GR probe and 50 ampere FG power supply can apply magnetic field gradients up to 20 Tesla per meter and measure slow diffusion behavior with diffusion coefficients on the order of 10 to -14 power square meter per second, making it useful for diffusion measurements on solid electrolytes. Sample is packed in a normal sample tube for solution NMR by using the airtight packing tool and placed in the sample holder. Choose 7 lithium as observation nuclei and set array parameters for field gradient. As the magnetic field gradient is increased, the NMR echo signal decreases. The diffusion coefficient D is obtained from the degree of signal attenuation. By measuring diffusion coefficients at various temperatures, activation energies can be determined.